This math review is about basic trigonometry. We're going to use this a lot all the time in physics, so it's important to remember some of your basic trig. We're going to start with a triangle. You can either have a right triangle or you can have a triangle that's not a right triangle. But either way, all of the interior angles of a triangle, if it's in a flat plane, will add up to be 180 degrees. That's a really important thing to know. If the triangle is not a right triangle, in other words, doesn't have a right angle in it, you can use the law of cosines to find the angles. Most of the time in physics, though, we'll just draw ourselves a right triangle so that we can use sine, cosine, and tangent. So in this particular drawing of the triangle, we have three corners A, B, C, and our longest side is going to be across from C. That'll make this side the hypotenuse. AB will have to be the hypotenuse. Now, if we were looking at it, let's say we're concerned with this angle, angle A, then the hypotenuse is always going to be across from side C because that's the biggest angle. If the three angles are 180 and this one's 90, well then B and A added together have to be 90. So that means that B or A could not be 90. So this is the biggest side angle. So across from it, opposite of it, will be the hypotenuse. That's the name we're given to the longest side of a right triangle. Okay, the adjacent side is the side that is next to the angle, touching the angle. And the other side is the opposite side, the side that's opposite of the angle. It's important to know which angle we're talking about, though, because in physics, sometimes we can draw the angle in a different place. If we wanted to look at this triangle from B, then what was our opposite side becomes our adjacent side and vice versa. Our hypotenuse is exactly in the same place because it's always going to be across from the largest angle, in this case, C. This is really important. I've seen students go to a tutor before and say, oh, well, your x-axis is always going to be cosine. Not necessarily. It depends on how the triangle is drawn. So keep this in mind. It will help you out. Okay, so triangle has to be a right triangle, or you would have to use the law of cosines. Generally speaking, we're going to try to make them into a right triangle. Hypotenuse is the longest side. It's across from the biggest angle. If we're talking about angle A, then the opposite side is over there, and the adjacent side is down at the bottom, down here. If, however, we're looking at a triangle with the angle of B, then the hypotenuse is in the same place, but the opposite side is now on the bottom, and the adjacent side is on the side. All right, trig ratios. Ancient Greeks figured out a long, long time ago that for it to be a triangle, it has to have certain ratios. In other words, the sides aren't going to line up into a triangle shape unless these ratios are appropriate for that to happen. So there's three different ratios that we can make here, or that we're going to look at. The opposite over the hypotenuse, the adjacent over the hypotenuse, or the opposite over the adjacent. And when we use these angles, again, if we flip them, then the ratios are still the same as before. Okay, so that part doesn't matter, but the angle that we're going to use will. One way to remember this is in high school you might have heard of SOHCAHTOA. Okay, that's a mnemonic device to help remember that the sine, S-O-H, sine, is equal to opposite over hypotenuse. The sine of angle A is the opposite over the hypotenuse. The cosine of angle A is the adjacent over the hypotenuse. And the tangent will be the opposite over the adjacent. It won't be a triangle if that's not true. Okay, so you calculate that and you can make a big chart of all of these different ratios. And in the olden days, before we had calculators like we do now, we had to look up in the back of the book on a table of all those ratios when we needed the sine of 56. Now you can just punch it in your calculator. So much easier. Okay. So, SOHCAHTOA. Lots of different stories about, the one of them that I've heard is the famous Indian princess SOHCAHTOA, and then you can develop the story with the triangle and whatever. But the mnemonic is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So just like we've said on the previous slide, it makes it easy to remember that way. Okay, so here are some examples of some trig ratios. If we're looking for, in this case, the sine of angle P, here, this would be our opposite side, this would be our adjacent side, it would be 16 over 20. Cosine of P is going to be 12 over 20, tangent of P is going to be 16 over 12. Well, if we change the angle that we're looking at, if we're looking at from Q, the sine of Q is going to be 12 over 20, the cosine is 16 over 20, and tangent is 12 over 16. So you can kind of see from the angles over here to the angles over here, you see some of the same numbers. The sine and cosine are reversed, and the tangent is flipped on its head. That's kind of some important stuff, but that's just the way math works. All right. Here's another one that's going to be important for us. As an example, if we have a skier going down a slope, when we find the angle Q, if this was the slope the skier was going down, when we draw a line straight down due to mass or gravity, the angle that that's going to make with the surface PQ is going to be the exact same angle as Q. And the reason it's the same angle is because of this, and because if you bisect two parallel lines, the way the angles line up. But it makes our physics pretty easy. In this case, what we're saying is triangle ABC is proportional to triangle QPR. And so if we know the angles on one, we'll know the angles on the other. They're similar triangles. And you can see that the ratios are the same. You'll get the same number. Okay, so for a triangle to be similar, the lengths of the corresponding sides have to be the same, and the angles, if that is true, will be the same as in the small one as the big one. And all similar triangles have the same trig ratios for the corresponding angles. I hope that helps you with your review, and look forward to seeing you in class.